Some friends here in the valley asked if I could make them a door knocker. So today, let's take a look at making this door knocker. The videos at Black Bear Forge are made possible in part by viewer donations through Patreon and YouTube channel memberships. For a door knocker, I'm going to start with a piece of 5/8 bar, and I'm going to weld a collar in the middle. That's going to make a big knob that actually does the knocking. Once that's on, we're going to taper the bars out, put a twist. So the length of the bar isn't critical right now. I will trim it off during that process once I know exactly how much bar I need and I get the twist the way I want it. Now that collar will be made from a piece of 3/8 by 3/4 inch stock. It'll be bent to wrap around, cut off, forge welded in place. So the first step is to find center on the bar and upset it some so that there's enough mass there to get the forge weld without making the bar thinner than I want it. I'll center punch that so I know where my upset has to go. This is a situation where the ability to take an isolated heat with either a torch or an induction forge, something like that, really pays off. But if you don't have those, you can selectively cool the areas that are hotter than you want them to be. Using a low upsetting block like the anvil the other shop has would be the best way of doing this, but I find the step to be pretty good because it supports the end of the bar and it keeps the struck end a little bit lower, which is more ergonomic. Now to form that ball in the middle of this bar, I want to make a collar, and because of the square bar, it's pretty simple to measure the collar. You want to go from center line to center line of the collar material. So in this example, I'm using 5/8 bar, I'm using 3/8 material, so it's 3/16 on either side, or you can just figure, well, 3/8 and 5/8 is 8/8 or 1 inch. So you need 1 inch of material for each side of the collar, or 4 inches. Simple math in this case. And you have to figure this out for whatever material you're using. That just works in these sizes of material. So I'm going to mark that at 4 inches, and then I'm going to find the center point and come out 5/16 of an inch on either side of that. So I have 5/8 of an inch laid out, and I'm going to put that in the vise and I'm going to bend it. I'm also putting a slight bevel on this so it'll overlap just a little bit. This block is the same thickness as the bar this has to go around, and using the block provides clearance so the vise jaws aren't in my way. Okay, that'll stay on the bar now. Get a much better heat. If you're doing a bunch of collars that are all the same size, it pays to make a bottom tool for the anvil that is the same size as the collar, and that way you don't have to worry about a vise slipping. You just drop in the tool, put your material on top of it, and close up the collar. Much faster, much easier. But since this is a one-off project, I didn't take the time to do that. Light, rapid hammer blows set the weld, and I want to make sure that weld is good and solid before I start working this to shape that into a round ball. I've taken 3 heats to refine the ball on this. The first 2 are at welding heat. This last one's lower so that it leaves a smoother surface. Got a nice ball detail in the middle of this bar now. Nicely welded. I did overcook the bar a little bit, so as I taper this out, I'm going to try and forge it a little skinnier and hope I can get that roughness from that slight amount of burning while I was coming up to welding heat and get all that cleaned up and smoothed out. I think there's plenty of material to pull that off. Now when I bend this into a circle, I'm going to work over this section of tubing here. And this is 3.5 inches in diameter. So the inside of my ring will be 3.5 inches in diameter. Again, anytime you do any measuring, you're measuring from the center line of the bar. So I need to add 5/8 of an inch to that, or 5/16 on each side, still 5/8. So it'd be 4 1/8 to the center line of the handle, multiplied times pi, which is 3.14. Or in this instance, because I'm going to taper it out, it's going to get a little bit too long. I'm going to have to come back and trim it anyways. I'm just going to go 4 times 3, which would require this to be about 12 inches. And again, because I'm going to taper it, I think I'll just cut it 10 inches. That's not hardcore math, and the amount of taper on this doesn't really matter. So if I've got to taper it out a little bit more to get this to fit, that's fine. If the ends overlap a little bit in the end, I can trim them so I can get them exactly the way I want them on the inside of the pivot point. Because this tool fits the Hardy shank on my other anvil and does not fit this anvil, and because the sun is about to come in here and make it really hard to get good video lighting, and everything's going to be really contrasty in just about 10 or 15 minutes here, I'm going to move back over to the other shop. We'll turn on the gas forge, and we'll do this in the gas forge. Drawing out over the horn is a little bit faster and more efficient than drawing out at the face of the anvil. I will, however, straighten it and make sure it's a nice clean taper at the face. Now I need to bend this around my form, and if you've been thinking about this while you watch the progress so far, You're probably wondering, what are we going to do with this big knob right here in the middle? I think the solution is just cut a notch out of the side of the form that'll fit that, so that the square bar is what goes right up against the side of the form, and the knob just has some relief there. This form is tall enough that I don't think it's going to be a problem if I cut a notch down into here. I've still got lots of tube for anything else I might do with it. That gets the ring portion of our door knocker done, and this is the most complicated portion of the project. Everything else is a lot easier from this point on, and there are so many different possibilities of how you design back plates and things like that, that you can take this in any direction you want to. The person I'm making this for had a very specific back plate design, so that's what I'm going to make. And I'm going to start that with this piece of 1/4 by 3-inch flat bar. Right now this is about 10 inches long. I'm going to start by trimming this. It's kind of a long pear-shaped tapers, scrolls at the top. Probably saw it on the thumbnail. But I think I want to start just by removing some of this excess material, trying to forge and draw out material that is 12 times taller than it is thick. Is just a recipe for folding this over and creating cold shuts. I don't want to do that, so I'm going to go ahead and trim these corners off, then I'll forge it to shape. This trimming can be done with any cutting tool you have, pretty much. You can do it with a chisel hot at the anvil or under a treadle hammer. You can do it with a plasma cutter, an angle grinder, bandsaw. Since I've already got the plasma cutter set up, I think that's the way I'm going to go. I don't want the ring on this door knocker to spin inside the keeper, so I'm going to put a little partition in there that prevents the ring from spinning around in circles. Well, here is our completed door knocker. It is very much in that same style that my friends wanted. A little bit different. I took some artistic license, probably a little bit heavier and bulkier. I hope they got a good solid front door to put this on. Of course, I will provide color match screws that are treated with the same wax finish that the door knocker is, and that way everything goes together. If you're working in a small shop, working primarily by hand, forge welding this collar on, I think, is way easier than trying to upset that much mass into a bar, although it would have been easier to upset that in the induction forge or using a torch. I think I mentioned that. But that's still a whole lot of work, and forge welding that collar on is probably easier, even though technically more difficult. Now in my shop, if I were going to do repetitive similar projects, I would probably make a set of spring dies to use under the power hammer that refine this ball. I'd rough out a piece of maybe 1.5 inch round bar to get it close to the shape I wanted, go under the dies, get the ball refined. It would be very regular, very repeatable, and it would probably be faster and easier than doing the forge weld. Although there may still be an argument for doing the forge welded collar and then going under the dies just to refine it and get everything even. Perhaps the most fiddly thing is getting these tapered twists right. I did lots of little spot heating with the torch just so those twists would twist up even, and I think that's really worth doing. If you leave the bar parallel, it's a lot easier to get an even twist. But the thin spots twist way faster than the thick spots, so it's something you have to pay attention to. I hope you enjoyed this project. I want to thank you for taking your time to watch the video. With special thanks to my Patreon patrons and my channel members. Videos like this wouldn't be possible without viewer support, and the donations that come in through Patreon and channel members really help. Channel members get early release of the video a day or two early. The paid Patreon members not only get the early release, but they also get the video ad-free over on Patreon. Other than that, it's the same video you're watching here on YouTube in most cases. Anyways, thanks again for stopping by. I hope you have time in your day to get into your shop, make something, stay safe, have fun, wear your safety glasses. We'll see you for the next video.